In this lesson, you will learn about the Pythagorean Theorem. Let's take a look at what the Pythagorean Theorem is. Why do we use the Pythagorean Theorem? The Pythagorean Theorem is used to find the missing side of a right triangle. So here we have a right triangle. If we knew two of its sides, so for example, one side is 4 centimeters, another is 3 centimeters, using the Pythagorean Theorem, we can find the third or missing side as long as we have a right triangle. Now just to make sure you understand, a right triangle must have a right angle. And this little box signifies that that is a right angle which measures 90 degrees. And again, the Pythagorean Theorem only works if you have a right triangle. So let's take a look at what the Pythagorean Theorem looks like. Here we have a squared plus b squared equals c squared. This is what we call the Pythagorean Theorem, and it helps you to figure out a missing side of a right triangle. First, you must understand what side of a triangle is A, B, and C. If I draw a smaller right triangle, C is always going to be the side across from the right angle, or the longest side. The A and the B, it doesn't really matter which side is the A and which is the B of the two legs of the triangle. So those can be interchanged. So by understanding that, if you look at the triangle given in this particular problem, the A we could identify as the side with 4 centimeters, the B could be the side that has 3 centimeters, and the C is definitely the X because that's the longest side, or the side across from the right angle. So to solve for X, we're going to plug in the values for A and B into the Pythagorean Theorem, and then we will solve for C. So A is 4, so we're going to put 4 squared. B is 3, so we'll write 3 squared, and the C will remain C because it's an unknown, or you could write X. We would then simplify 4 squared and 3 squared, giving us 16 plus 9 is equal to C squared. Now 16 plus 9 is 25. So once we get down to this point, we want to know that what number could C be so that if it were squared, it would equal 25. There are actually two options. We have 5 times 5 equaling 25, or we have negative 5 times negative 5. So both 5 and negative 5 would work. However, in this situation, the length of the side of a triangle could never be a negative value, so we would want to choose the positive value. So basically what we're doing is taking the square root of both sides, and the square root of c squared is simply c, because c times c equals c squared, and the square root of 25, although it could be either positive or negative 5, and this symbol indicates positive or negative, we're going to choose the positive because for this situation, it's the only logical answer. So the missing side length would be 5 centimeters. Let's go ahead and look at an additional problem. In this problem, we first want to again identify side A, B, and C. Start with C, which again is the longest side, or the side across from the right angle. And once you have C, again, it does not matter which of the two remaining sides you label A and B. This time, B is missing. So we're going to replace A with 10, so we have 10 squared, plus B squared, and then we'll replace C with 26. Now we're going to go ahead and simplify 10 squared and 26 squared. 10 squared is 100, so we have 100 plus b squared, and 26 squared is 676. In order to solve this for b, we need to isolate the b. So we will subtract the 100 from both sides to move it over with the 676. That would leave us with b squared equaling 576. From here, we would want to take the square root of 576. Now you may not know what the square root of 576 is, but if you use a calculator, then you will see that the square root of 576 is both positive or negative 24. But again, we would only want to use the positive value because that would make logical sense for this problem. So our missing value of x then would be 24 inches for this particular problem. In this next problem, again, we want to first identify the a, the b, and the c. So this time the c would be 15, and then again we can label either the 7 or the x as the a or the b. So I'm going to replace the a with 7, so we have 7 squared plus b squared equals 15 squared. Simplifying the 7 squared and 15 squared gives us 49 plus b squared equals 225. If we then subtract 225 minus 49, we can then find out what we have left on the right side of the equal sign. Now, if you take the square root of both sides, 176 is not a perfect square. If you put 176 in the calculator and take the square root of it, you would get approximately, if you round it to the nearest tenths place, it'd be 13.3. So we have 13.3 inches. Now, if you did not have a calculator, you would want to just estimate, since 176 is between the perfect squares 144 and 196, excuse me, 169 and 196, which would be between 13 and 14, you would know the answer would be somewhere between 13 and 14. Because it's less than halfway, 13.3 would be a good estimate. In this last problem, it simply says determine whether 9, 12, and 16 can be sides of a right triangle. So in other words, if we actually labeled these, 16 would be our longest side, or our C, and then one would be 9 and one would be 12. We want to know if this is legitimately a right triangle. To do that, we would simply plug it into the Pythagorean theorem. So A, I could put 9, B, 12, and then C, 16. And I just have to see whether or not the left side, when I square the 9 and the 12 and find their sum, equals 16 squared. So we would have 81 plus 144, and we want to know if that equals 16 squared, which is 256. So let's go ahead and add 81 and 144, and we actually get 225. Since it's not equal to 256, then we can determine that these are not, or these lengths do not form a right triangle. And this completes the lesson on the Pythagorean theorem.